I'm Linda Prinsloo. I'm a research fellow here at the University of Wollongong, and I specialize in vibrational spectroscopy. Vibrational spectroscopy is the study of the vibrations of molecules. At room temperature, all molecules are moving around, and if you heat them, they will move at a higher energy. So I can use this to have a fingerprint of different kinds of molecules as they all move at different frequencies or vibrate at different frequencies, to use a more scientific term. So there are two ways in which I can do it. The one is Raman spectroscopy, and the other one is FTIR spectroscopy. Now, in both techniques, I add energy to the molecules, and then I measure at what energy they vibrate. Now, you might ask me, what will that help me to know what a molecule is? So if you think about a little mouse jumping on a trampoline, it will be doof, 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 doof. So that little mouse will send out vibrations of a certain frequency. And if you were to put the elephant on the same trampoline, it would be more something like doof, doof, doof. So even if I don't know or can see it's the elephant or the mouse, the vibrations will tell me which one it is. So if I have a database of vibrations of a large number of molecules, I can select those that are of interest to me, and I can compare it to known samples.
So I'm an analytical chemist, and I'm interested in looking at organic residues on stone tools as well as in the sediment, just to try to piece together the chemical processes that occurred at the site, and also work out how the hobbit lived, basically. I use mass spectrometry. It's a technique used to analyse individual molecules found in the specimen, so we can piece together everything is made out of molecules. And so if we can get a profile of the molecular identity of the things that we will find on stone tools, it might help us understand what the hobbit ate, how they lived. Together with Matt, Thomas, Mike and Richard, we wrote a sampling protocol which was applied in the field. So we do have input on how the samples are collected. We just don't do it ourselves, obviously, because the archaeologists do that. And then from the site, the samples get sent to the lab where Richard has a look at them for use wet analysis and also microscopy, and he identifies or screens the stone tools for any interesting residues that we may find. And then if there is anything interesting, then it will come to Linda and Luke, which work on spectroscopy, and that's another good analytical technique to use to screen the stone tools and get some sort of molecular information of the composition of the sample. And then my step is the final step. It's a destructive method. We basically isolate the residue, process it so that it makes it amenable to mass spectrometry, and then identify the molecules and separate them in the sample.
Regarding the artifacts of Liangbua, we're basically looking at stone tools. And these stone tools have been used many, many years ago by the people who lived in the cave. And we hope that by using Raman and infrared spectroscopy, we can identify some of the molecules that became attached to the tools through the working of the people using the tool. So for instance, if someone were cutting meat with a tool, we would hope to find some remnants of bone, fatty acids, something like cholesterol on the artifact, while if they were working with plants, we would expect to find some cellulose or lignin, all the ingredients of plant materials on the tools. It is quite difficult because the samples are very old and some of the material has become degraded.
Obviously, an archaeological site is on a sterile site, and our technique requires quite sterile conditions. And so we have issues like contamination, people not wearing gloves, but that's expected at an archaeological site. So we just work within the confines of that environment. And also degradation. At Liangbua, it's quite hot, it's quite humid, and these conditions aren't very good for preservation of residues.
So in the laboratory we have to follow a process whereby we can eliminate some of the contamination that could have been left on the samples by the people who excavated the samples, people who put it in storage afterwards, and sometimes even by ourselves just handling the samples.
It's the last part of the analysis, and from the information gathered from everybody else, then we're ready to interpret properly. So there's a standing hypothesis. We go through the process of analysis. It's a multi-step approach, and then we either support or refute the hypothesis that was set. I'm not originally from archaeology, I'm an analytical chemist, but we're hoping to find some amazing things.